Exercise 8.6, very first question we have, he said divide 14 into two parts. Divide 14 into two parts such that the sum of their squares is minimum. So if one part, let us say, is x, then other part will be obviously 14 minus x, as we have to divide 14 into two parts. One part is 10, then other part will be 4 obviously. So if one part is x, other part is 14 minus x. Sum of their squares, let us say, represented by s. Sum of their squares. Sum of their squares. He said this must be minimum. That means we need to differentiate this. And already we have done it in single variable only. So it depends on x. So differentiate it with respect to x. So for maximum or minimum, put it equal to 0. For maximum or minimum, we do not know that it is maximum or minimum. We do not know at this particular point. That will come to know after second derivative only. If we put second derivative, then we will come to know maximum or minimum, because you can see from the graph that at this point, maximum point also, derivative 0, minimum point also. So at all the critical values, you can say for the critical values, put it equal to 0. We got x is equal to 14 minus x. 2 and 2 cancel out. This is negative. On this side, it will be positive. So we got 2x is equal to 14 and x is equal to 7. Now at this particular point, find the double derivative. Double derivative for this is 2 minus twice of minus 1. That is, for 14 it is 0, for minus x it is minus 1, and this negative is here. So it is minus minus plus 4. 4 means it is positive. And as it is positive, so your s is minimum at x is equal to 7. So if one number is 7, from this equation, if one number is 7, then other number also will be 14 minus 7, 7. So at 14 is divided into two parts such that their sum of their squares will be minimum. Just write it down.